All right, 2.4. We're probably, like I said, if we finish it today, fine. If we don't finish it today, that's still fine. We'll come the closest we possibly can. We're going to talk about solutions for linear equality. So now here is what you just did in the previous class. In the previous class, we were dealing with solutions for two equations, remember? You had two equations that you had to type in decimals, or we learned how to solve them by two methods. What were the two methods?
Substitution and elimination.
Substitution and elimination. This time, we're going to solve algebraic, but they're going to be not equations, but inequalities. So when you hear the word inequalities, what symbols do we use for the inequalities? When something's not, what is it again? Equal sign with a slash through it. What's another sign that tells me that some things are not equal? They could be what? So here that's a not equal to symbol. And this also means something's not equal. It's either less than or greater than, but it ain't equal. Here's another one. And then, of course, you got the greater than and the greater than or equal to. All right, so what's the difference between this symbol and this symbol? I'm pointing to these two symbols here. What's the difference? Okay, one where it has the equal sign underneath it, then that's another situation. So just make sure you know the difference between all five of those symbols. Those are all inequality symbols. Means not equal to. So if something's not equal to it, it could be any of those five symbols that you see on the board. We're going to learn how to solve them. We're mostly going to do the algebraic solution for them. You really won't use the graphical solution for them. We're going to find the x-intercept and then look at double inequalities. So here is, next slide. Here. All right, we just talked about what the inequality means, so you've got the symbols for it. Here's the next. Now, when we solve them, we're still going to get a solution. Remember the word we used last time when you're solving inequalities or solving equations? You are still going to get a solution. In this particular case, it could be a solution set. What do I mean when I say solution set? It could be a set of numbers. In the last one, when we solved the two equations, did you get a set of numbers? You had three options. Either they're going to cross where? At one point, or what were the other two options? Infinitely many solutions, or there's no solution at all. In this particular case, you can get a set of numbers. So for example, the solution could be a set of all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a set of numbers. Or it could be all the numbers greater than 0. That's another set of numbers. So when it says solution set, just make sure it could be a group of numbers. All right, we're going to show you how to write it multiple ways. Your answer or your solution can be written multiple ways. One way to write your solution is in inequality form, which you see on the board. And another way to write your solution is in interval notation form. Both of those on the homework is going to ask you to either write it in inequality form or interval notation form. So I'll show you how to do that as we get to the first example. Or you could also graph it. So you've got three ways you can write your symbol. Inequalities mean you're going to use less than, greater than, less than or equal to, greater than or equal to. Those are your inequality symbols. So if it wants you to write your answer with inequalities, it wants one of those symbols. If it wants you to write it in interval notations, you're going to use brackets and parentheses or a combination of both. That's interval notation, and there will be a comma in between whatever numbers you put in there. That's interval notation. Parentheses, brackets, or a combination of both. The last bullet says your answer could be written as a graph of a number line. So we could graph something here and shade everything going this way. So this is an example of, it could be 3, and I shaded everything to the right of 3. That's an example of how you would graph the solution. You just do a shading on the number line. There's a reason why there's a parentheses on this number line, which we'll talk about in a second. And you probably have seen some of this before. So let's go on to the example. Alrighty, so here's our first example that we're going to actually do. So you can see how to write it in all three notations and how to solve it. Alrighty, so here we go. What symbol do we have in the middle here? What inequality? Less than or equal to? Okay, alrighty. So now I'm gonna solve it just like as if it had a regular equal sign in it. I'm gonna get x by itself on the left. I specifically want it to be on the left. You know, before we could say x can be on the left or the right side of the equal sign, we specifically want to keep the x on the left. So I'm gonna do whatever I have to do to make sure this x, there's no x's on this side of that less than symbol. So what should I do first? Bring x over, which means I gotta add whatever that is. Symbol is a minus x. I gotta do the opposite, which was add x to both sides. So I'm gonna add an x over here. All right, so I've got 3x minus 7 is less than or equal to 5 minus x. I just added x to both sides, which is gonna cause this minus x plus x to cancel out. What's left? Well, I've got a 3x plus an x. How much is that? 4x. 4x. Minus 7 is less than or equal to 5. Do I have x by itself yet? No. What should we do? Add 7 to both sides. So the negative 7 and the positive 7 cancels. I have 4x is less than or equal to 12. That should be a 7. Alrighty. Do what now? I still got to get rid of that 4, so we can divide both sides by 4. All right, divide that side by 4, divide this side by 4. The 4's cancel out, so x is less than or equal to 3. Now, what does that say? It says that in order for this to be a true statement, your original statement to be true, you can only pick what kind of numbers?
Numbers that are less than or equal to.
You can only pick numbers that are less than or equal to 3. So if I plug in a 3, will that make this side less than that side? Yes. If I plug in a 2, will it make this side less than that side? Yes. Well, let's try it and see. Just to prove to see, 3 times I'm going to plug in a 2. So if I plug in a 2, I've got a 2 here. Minus 7 is less than or equal to 5 minus a 2. All right, well, let's do the math. What's 3 times 2?
6.
And what's 6 minus 7?
1.
Okay, so I've got a negative 1 on this side. And over here, what's 5 minus 2? Is negative 1 less than 3? So it's a true statement. So the only numbers that'll make this work are numbers what? Less than or equal to 3. Could I plug in a 3? Yes, because it says less than or equal to 3. So I can plug in 3, 2, 1, 0, negative 1, negative 2, all the way going what direction? To the left. All right. So we just did this just to check and make sure our answer actually works. So you don't have to check it unless you just want to. So now, this is your solution. How do I write my solution? 3 ways. And the homework is going to ask you to write it 3 separate ways. What's this way called? Inequality form or inequality notation. When it has the less than or greater than symbol in it, it's called the inequality form or the inequality notation. So that's the first type of answer they're going to ask you to write in inequality form or inequality notation. It doesn't matter which word you use. Inequality notation. Alrighty. The next one I'm going to show you how to do is called graph form or graphical notation. Okay, graphical notation, I just want to shade what it says I can shade. What does it say I can only pick what kind of numbers? Okay, so I'm going to put 0, 1, 2, and 3 on my number line. I don't need to write the other ones. Alrighty, so what direction should I be shading if I want all the numbers less than or equal to 3? On the left. Now here's the question. I'm going to shade everything going this direction. Do I shade the arrow? Well, do I stop at a number? Do we stop at a specific number?
No.
If it says less than 3, can I pick 1 million, negative 1 million? Can I pick negative 2 million? Negative 5 million? So does this stop? No, it doesn't stop. We're shading the arrow also. It just says that we can keep picking numbers in the negative direction forever. All right, one thing I have not done. Now, Did it say I could include the 3 as one of my numbers I could pick? So because I can include the 3, we're gonna bracket. Bracket means include. You may have seen it as a closed circle or open circle. Closed circle also means, so if you see it with a closed dot, that also means include. So closed dot or bracket means to include. The equal sign tells you that 3 is one of those numbers you can plug in. So that's what your graphical notation should look like if they say write it in graph form. I'm picking all the numbers less than or equal to 3. So here is interval notation. All right, interval notation looks like this. It uses brackets and parentheses and or both. Well, if you look at the graph form, did I use a bracket? Yes. So we want to use the exact same thing that you did on the graph. So since we used the bracket, I'm going to use a bracket. Where did we put our bracket? On what number?
3.
So I'm going to put a 3 in a bracket. The bracket should be the exact same direction. It should open the same direction as it does on the graph. So if it opens that way on 3, you should open it that way on 3. Did it stop? Did we stop this?
No.
Did we pick a number and stop?
No.
What symbol do we use that goes on forever and ever and ever and ever? Infinity symbol. And whenever you have an infinity symbol, you have to close it with a parentheses because it doesn't stop on a number. Can't use a bracket because the bracket stops on one particular number. Parentheses does not stop on that number. Does not include that number. It just says it goes on. In this case, infinity will always have a parentheses. Infinity will always have a parentheses to close it off. Doesn't stop it. It's just what we have to do to write it in interval notation. So you've got 3 different ways of writing your answer or your solution. The first one is called the inequality notation. The second one is graphical notation. The third one is interval notation. Yes, ma'am.
Should that be negative infinity or
It should be a negative infinity. Thank you. We are going the negative direction, right? Thank you. Questions? Okay? Alrighty, so you know all 3 ways to write this. Here is, we're not going to do the graphical solution. We're going to do another, did I go up or down? The graphical solution is just a number line. So it's like there's nothing special about the graphical solution. So when they say solve it graphically, you're just solving the equation and putting it in graph form. There's nothing special about graphical. It's just a number line. That's it. Yes, ma'am.
what's the open circle?
The open circle means we're not going to include, which we're going to, let me see if I should have one of those in here, which means we're not going to include, and it's in the, let's see. Yeah, that's double inequality. Let me do another one with the open parentheses. This one is not on your slides, but here we go. I've got 3, and we're gonna do x plus 5 is greater than, and let's not use equal to, I'm just gonna use greater than 10. I just created just a different one just to show you what happens if you don't have an equal to sign underneath it. Alrighty, am I going to try to get x by itself on the left? Yeah. Do I have to move any x's around? No, it's already got the x over here, but it's just not by itself. How do I get it by itself? I am going to eventually divide by 3. What should I got to do first before I can divide by 3? I got to subtract 5 from both sides. So the 5 minus 5 is going to cancel. So I'm left with 3x is greater than, what is it? 5. Alrighty. Divide both sides by 3. So x is what? Greater than 5 over 3. Now you can leave that answer just like that. Now I know 3 goes into 5 1 point something times, right? Should be 1 2/3 or 1.6. I'm just gonna write this over here. It's approximately 1.66666. So that's approximately 1.6. I just made a note for myself. So when I do my number line, I know where to put it. All right. So we got what form? What form is this in? You got 3 different forms that you can write your answer. Inequality. The next one we're going to do is graphical form. So here's graphical form. I need a number line every single time for graphical form. Where am I gonna put my number that's important to me to note? Over here, what was the important number? 3. What's the important number here? 5/3 or 5/3, which is approximately 1.66666. You okay? So somewhere on this number line, there's 0, there's 1, there's 2. Where's 1.6? Somewhere in between there, okay? So somewhere in between there, I'm just saying there is 5/3 somewhere in there. I'm not trying to make it dark. I just want you to notice that's where it is. That's not 15, it's 5/3. All righty, we're good? You always have to go find where this number is on the number line. Always. That's the only way you can graph it. You got to know where that number is first. Once we find it, now, did it have an equal to sign underneath or not?
No.
It did not. So when there's no equal sign, we're going to use a parentheses. Now the question is, do I use the parentheses that opens that direction or this direction? Well, whatever direction this symbol is pointing, that's where your parentheses should open. So it's pointing which direction? To the right. So I'm going to put a open parentheses on 5/3, and I'm going to open it in the direction of this greater than symbol. Because it says I can pick all the numbers bigger than 5/3, right? So all the numbers bigger got to go on that side. So I'm going to shade everything in that direction, including the inequality, including the arrow. Include your arrow. You okay with that? All right. That's the graphical notation. All right. When do you use the parentheses? If it doesn't have an equal sign underneath the greater than and less than symbols, if they don't have equal to signs, you have to use a parentheses. Whenever you have an infinity symbol, you have to use a parentheses to close the infinity symbol. All right, so let's write it in interval notation. All right, I got inequality, I got graphical, I need inequality. What kind of symbol am I going to put first? The open parentheses, just like you see on the graph. So if it's got an open that way, you should open it down here that way. On what number did we put the parentheses? On 5/3. Did we go on and on forever?
Yes.
Put a positive infinity, and you always close the infinity with a parentheses. So you got all three notations. So, open circle, this is open. So if you see parentheses, meaning we do not have an equal sign, that's an open circle. So in the homework, I think they use mostly parentheses, but just in case they use open circles and parentheses, when you see no equal sign, means open circle or parentheses. If you see an equal sign, that's closed circle or bracket.
As Eric said, the last one, that's the interval notation.
Yes. Yes. So this is inequality notation. This is graph notation. And then this last one is interval notation. Questions?
Will the homework want the decimal or the fraction?
The fraction, or it'll specify. So let me not say that it should specify. It should say simplify in integer or simplified fraction form. If it wants decimal, it will tell you how many decimal places it wants. But most cases, this one's going to usually want a fraction. Alrighty, here is the next one. We're going to talk about double inequalities. What does double mean? You're going to have two of them. So instead of one less than or greater than symbol, how many are you going to have? Two of them. Well, there we go. Can I erase what's on this board right here?
Yeah.
Okay. All right. I'm going to leave what's on the left side there. And let's work this one out. Now, what did we say we wanted to do with the x on the last one? Where do we want our x to be in the last two examples we did? On the left. When there's two inequality symbols, we want the x to stay in the middle. when there's two inequality symbols, we want the x to stay in the middle. And the answer has to keep the less than symbols. They can never be greater than. If they are greater than, we got to flip it around. Your answer always has to stay in less than. It's always got to keep its less than symbols. Always, always. If they ain't less than symbols, then you ain't finished. So, all right, let's work this one out. So I want to keep this x in the middle. So I got to get rid of this -5 and that 3. So whatever you do in the middle, you guess what you got to do on the right and the left. So first step, add 5 in the middle. So that means where am I going to add 5 also? On the left and the right. So I'm going to add 5 over here, and then I'm going to add 5 over here. All right, so the 5 minus 5 in the middle cancels out. So what am I left with in the middle? 3x is less than 36, and 3x is, that's going to be 22. And I should have my less than or equal to symbol still here. Do I have x in the middle by itself? Not quite. What should I do? Divide all 3 sides by 3. The 3's in the middle cancel out. So I have my x in the middle left by itself. My less than symbol still just come down. What's 36 divided by 3? 12. Okay. And 22 divided by 3, we're going to leave it as 22 divided by 3. Okay? Now, that's your inequality answer. That's the inequality form of the answer. Solution. That is the inequality form. As long as it's still got the less than symbols in it, it's in inequality form. How do I write it in graph form? Now, here's what this means. When you see 2 less than symbols, the shorthand word is in between. I want all the numbers in between here and here. So what did I just say? This is shorthand for what? In between. So this is all the x values, and all the numbers you can pick in between 22 over 3 and 12. Can I graph all the numbers in between on the number line? Sure we can. All right, well let's graph. Well, I know where 12 is. I'm going to put 12 right here. There's 12. All righty. Well, now I need to know 3 goes into 22 how many times approximately? 7 times. So I'm just going to go over here and find 7. I'm just going to say 7 point something. Is 7.3. All right. So there's 22.3 is somewhere right here. 22 over 3, which is equal to 7.3, is right about there. Now, it says I want to shade all the numbers in between those 2 numbers. So we can shade that. All the numbers in between. All right, here's my blue for shading all the numbers in between. The question is, do I put open circles, closed circles, or brackets or parentheses? Okay, where you see an equal sign, you should put a bracket. Where you see no equal sign, you should put a done. And you got to close the area that you're shading in between for. So the brackets and parentheses have to face each other. Because we're shading an in-between section. That always means in between. When you see a less than symbol, an X in the middle, and another less than symbol, always it means in between. All righty, so now we've done the inequality notation. We just did the graphical notation. Now we got to do the the interval notation. Well, interval notation is now easy. Just look at the graph. Do you have a bracket? So you put a bracket, and what number did we put it on? 22. And then do you have a parentheses? What number did you put it on? Done. Literally just pick it right off the graph. You literally just pick it right from the graph. Don't do anything special, just take it right off the graph. So when I do these, to do interval notation, it's easy if I will graph it first. If you'll graph it first, it makes it easy to see what you need to turn into interval notation if you'll always graph it first. Questions? Alrighty. Alrighty. Everything relates back to real life, right? All of this does. Alrighty. So, let's see if we understand what we're talking about here. Okay, according to the data from the National Vital Statistics Report in 2010, the marriage rate, which we're talking about, when it says per thousand, it just means we're looking at 1,000 marriages each. So just look at a group of 1,000 marriages. So the marriage rate per thousand can be described by this function or this equation. So the marriage rate is Y. You see you got a Y and you got an X. The marriage rate is Y. And they're saying the equation for that marriage rate is negative 0.146x plus 11.074, where x is the number of years when? All right, so we ain't looking at the marriages before 1980. We're just looking at them after 1980. Okay, all right. For what years does this model indicate that the marriage rate was above 9? Okay, the marriage rate was above 9 marriages. Okay, so can I erase this guy? Okay. Okay, and this is marriages per 1,000 people, guys. I said that wrong. So we're looking at the marriages per 1,000. If you're looking at a group of 1,000, what's the marriage rate in that group of 1,000 people? Alrighty. So now, for what years does this model indicate that the marriage rate was above 9? What does the word above mean in math? Greater than. So in the place of that above, you're going to end up putting a greater than, above 9. Alrighty, where you see the other one was, we're going to go back and look and see where the marriage rate was below 8. What should I put? Less than 8. Alrighty, so far I'm going to write the equation, but in the place of where you see that we would usually put an equal sign, what am I going to put? Less than and greater than symbols. Okay? So let's write the equation with the symbols in there in its place. So over here, I'm going to put negative 0.146x plus 11.074 is greater than what? I want to know when the marriage rate is greater than 9. Remember, this is Y. Is Y the marriage rate? Yes. But this whole equation is the marriage rate. So I want to know when this whole equation is greater than 9. So can I solve and get x by itself?
Yes.
Yes. What should I do first? Subtract what? 11.074 from both sides. Somebody use a calculator, tell me what that is. 9 subtract 11.074. Say it again. Is that right? Okay, I need calculator again. Divide both sides by negative 0.146. Negative 0.146 on both sides. Those cancel out, so I end up with x is greater than what? I can't do this one in my head, y'all.
142.05. Which one are we doing?
I want you to tell me what negative 2.074 divided by negative 0.146 is.
Negative 14.
Okay, so I was thinking it should go into there more. Now, should it be negative or positive?
Positive.
Positive, okay. Check it again, guys. I just want to make sure that's right. Because I heard a couple of different answers. Just check it. Is it 14?
14.2.
14.2, so approximately 14. Okay. All right. So, is that the answer I'm going to plug in? But look at the question. It said what?
Year.
For what year? Is this a year? No. So, what did we go back and say X is? You got to always go back and read this one little statement right here. X is the what?
Number of years.
Number of years after. So, what do I got to do with that?
1980.
Uh-huh.
1990.
So now, when is the marriage rate, for what years is the marriage rate greater than 9?
1994.
For the years greater than 1994. It said, and notice it did say for what years. So it wasn't just 1 year, it's for all the years greater than 1994. Alrighty, so we're gonna do the same thing with the less than symbol? Yep. Oh, there's a mistake. I didn't catch my mistake. Guys, there's a mistake up on the board. What happens when you divide inequalities by a negative sign? What should happen? The symbol changes and goes the other direction. So, anytime you divide, if this number is negative and you divide both sides by negative, the symbol flips. It doesn't matter if this one's negative. It's only if that one's negative. So whenever that number is negative, this number flips. This symbol flops the other direction every single time. Every single time. So now all the age is what? All the years what? Less than. So where I put this word greater than, y'all don't make the same mistake I made too. But it's good for y'all to see me make mistakes.
You say that part again, when it's negative only on the left side?
So if this number, if you go to divide both sides by a negative number, so if you end up having a negative here and here, you gotta flip the symbol. You gotta flip it every single time.
So the one over top doesn't matter.
It does. If I had 3x is less than a negative 12, you wouldn't flip it.
Okay.
See, because you're gonna be divided by 3. So neither one of those numbers are gonna be negative. Only if what you divide by on the bottom here is negative, then you would end up flipping it. The flip symbol flips the other direction. So you should have a note here. Flip the symbol. Flip the symbol. Because of the negative sign on the bottom. So, the marriage rate was 9 for the years less than 1994. Okay, let's do the other part. So now, I've got to do the other part, which says, I'm going to use my less than symbol, so I want to know negative 0.146x plus 11.074 is going to be less than 8. I want to know when the marriage rate is going to be less than 8. Alrighty, I am going to subtract 11.074 from both sides again. 0.74. These two cancel out. I'm left with negative 0.146x is less than, and that's going to be, is that negative 3.074?
Yes.
Okay. Divide both sides by negative, which means what's going to happen?
The sign flips.
The sign is going to flip the other direction. All right, somebody do the math for me. What's that number going to be? Okay, 3.074 divided by 0.146 is?
21.
21? Is that the answer I heard? 21, okay. All right, so this number is going to equal 21, or greater than, so x is greater than 21. I don't know why I put 22. 21. All righty. So is that the answer I'm going to put in the computer?
No.
Nope, because I need to know for what years. So what should I do?
2001.
So, all righty. So for all the years, would you say, yeah. For all the years greater than what?
2001.
2001, the marriage rate was less than 8. For the years greater than 2001. Alrighty. Last one, because the last slide, you don't need to do the last slide. Last one that we're going to do. Let me erase what's over here so you see if you can read through that. All right, let's read through and see if we see what we see here. All righty, the temperature in degrees Fahrenheit. Okay, so the temperature in degrees Fahrenheit inside of a concert hall in minutes after a 40-minute power outage during a summer rock concert is given by T. What's T again? The temperature inside the concert hall. Alrighty, so the temperature T is equal to 0.43 M. What is M? It's minutes. Minutes when? It's the number of minutes when? After a 40-minute power outage, okay? So that's gonna be temperature equals 0.43 M plus 76.8. So let's make sure we understand what the topic is. All right, you went to the concert to see whoever. The AC wasn't working right. Okay? 40 minutes has passed by. Is the temperature going up? As the time, because we got all these people breathing in the room, right? So the temperature is gonna go up. So already 40 minutes has passed by. So we wanna know after that 40 minutes, we're gonna ask questions about the temperature after the 40 minutes has already passed. All right, so write and solve an inequality that describes the temperature in the hall. The temperature in the hall, when the temperature in the hall is not more than 85 degrees. What's the word not more than mean? So not more than, that's what I want to know what that word means. Less than, greater than, what is it? Less than? So not more, less than 85, not more than 85. Do I put an equal sign or not? Equal sign. This says not more than, so it could be equal to 85. So I need that not more than be less than or equal to. Alrighty, so I'm going to write that equation over here. So 0.43 M plus 76.8. I need to know when that's less than or equal to 85 degrees. I'm trying to figure out when the temperature is going to get down to 85, not down, but temperature's going up. I want to know when the temperature in the concert hall is going to get to 85 degrees, since the AC ain't working right. All right, what should I do first? Subtract 76.8 from both sides. All righty, so I've got 0.43 M is less than or equal to, what is that? What is it?
8.2.
Yeah, and that's a subtraction sign right there. Alrighty, divide both sides by 0.43.
19.
Alrighty, so let's see if we understand what we just figured out. Write and solve the inequality. We wrote the inequality, then we solved it, and it describes the temperature in the hall. When the temperature in the hall is not more than 85 degrees. We're trying to keep it to the, so that y'all ain't about to burn up in the hall. So we want to kind of watch it and see when it's not more than 85 degrees. When is that?
19.
When? 19 minutes when? After the 40 minutes has already passed by. So how many total minutes has passed by? 59 minutes. So 59 minutes later is when you can say that the temperature in the hall is not more than 85 degrees. Because it already said 40 minutes passed by. So you got to do the 40 minutes passed by. 40 minutes have already passed. All right, question. So, as long as 59 minutes ain't passed, the temperature is still 85 or less in the concert hall. Okay, question. You see how you kind of got to read it and work it out in your head as you try to make sure it makes sense? Because this happens in places. Don't ACs go out in summertime? In some places. So, question. That is the last slide. The next slide just has more problems that we could work out from a different section, but we're not going to do those. So you don't need to go there. So we have completed chapter 2. We have completed chapter 2. We will start chapter 3 on Monday. Let me stop this thing because I let it go for about 14 hours.